Hey there, MrAlgeBraun here. Welcome to my video of the day. And so in this one, we're going to be solving equations using the addition property of equality. And so let me switch to my desktop here so you can see what I'm doing and get my pen out. And there we go. You should be able to see that now. All right. So in this particular video, I'm actually doing two problems instead of one because neither one of them take very long. So I wanted to give you two examples. So the very first thing I would do here is take a look at this, this equation, and my variable is on the right and my number is on the left, and I'm adding a negative 18 to my variable, which I want to undo. So the first thing that I would do is go ahead and flip this, move this part to the left and this part to the right, and that's this symmetry problem or symmetric property. And so I'm going to end up with D minus 18. And so plus and negative is the same thing as saying subtraction. And so that's going to equal 61. And that's negative. And so the next step that I want to do here is add 18 to both sides. And what I do to one side, I always do to the other. And so let me explain that for a second. Our goal here is to get the variable by itself, and this negative 18 or minus 18 is attached to it, and I want to undo that. So a negative 18 plus a positive 18 is going to get this to cancel out, and that's what I want to happen. So this equals 0. So let me, I'll leave that there. I was going to erase the box, but I'll leave it there. All we have left is the D, and that's going to be equal to the math of this. Now you can, I encourage my students to do this out in the margin and leave their work. So I'm adding integers, they're opposite signs, so I need to find the difference. And so this is actually subtraction. So I'm going to subtract this and borrow that 5 there. And so this ends up being a 3, and this ends up being a 4. So 43. Now I need to come back and look at the numbers 61 and 18. This one's bigger. So in essence, I'm taking the absolute value of these numbers. So what's the absolute value of negative 61? What's the absolute value of positive 18? Well, 61 would be bigger, and its original sign was negative. So my answer here is negative. So negative 43. All right, so what I want to do is always check this. That's why I have the equation written twice. So some teachers don't have you check. Some make it optional. For me in my classes, I make it required in the chapter that we're working on. So for me, this is chapter 2. And so I would require this for all of chapter 2, and then after that it would be optional. But I want to make sure that we drive home how to use the tool, and so I do require it. If you are watching this video because you need help with it, you probably should be doing the check, okay? So D is 43. One of the things that I push in my class is that we copy down the original problem. We substitute in what we know for the variable on the second line. So this is negative 43. And I'm going to stay in blue here because everything else stays the same. I didn't get the color change there, so let me fix that. So negative 61 equals my negative 43 plus a negative 18. Now you could have written minus 18 because that means the same thing, but that's what I'm going to be thinking about as I do this. And so negative 61 is going to equal, again, if I need to do math, I'm going to do that out in the margin, and in my class I ask you to not erase that so that as a teacher I can come back and see maybe what your mistake was and be able to help you a little better. If you erase it, I can't do that. But these are both negatives, so when adding integers of like signs, we're going to add the numbers and keep the sign. And so I want to add the numbers, and so this is going to be an 11, this is going to be a 6 because I carried a 1, and so we get a 61. So adding, we're going to add and keep the sign, so this would be negative. So this is a valid check. I get a true statement here, and when that happens, this is a valid check, and I have a high probability of getting this right. Now, I always say high probability. Why? Because I could make a mistake and then make a mistake in the check. that coincidentally gives me the right answer by accident, and I could think that I have a false positive here and it's actually wrong. So a check is not a guarantee, but it does give you a high probability of getting the answer right. Okay, all right, so I wanted to do a second problem, and this one I purposely picked some fractions. And so the same thing's happening here. My y is on the right and my number is on the left. So I'm going to go ahead and copy that and switch it. So y minus 3/5. And actually at the same time, I'm going to think about the common denominator. So I don't want to put this over 5. I want to put this over 10. Because the least common denominator of 10 and 5 would be 10. And so I took that times 2. So I'm going to take this one times 2. And the times 2 part you don't necessarily have to write down. Just doing that for discussion's sake. But this would be over 6. And so equals. And then this is going to be negative 7/10. All right, so the next step, let me switch colors here. I want to add, again, I'm doing the opposite of what's here, so this cancels out. So add 6/10. And what I do to one side, I do to the other. So we're going to add 6/10 here. And if you notice, these are numbers. I get them to line up. These are fractions. I might have wanted this to be over here, but I'm already using a line, so I wrote it down below. But these will cancel out. This one's negative, this one's positive, and that gets them to cancel out. So y equals, and then negative 7 plus 6 is going to give me a negative 1. So I'm going to get negative 1 over 10. And you can take the negative sign out front, or you can put it in the numerator. You're able to go either way, and that's acceptable in algebra. And so what I would do is come over here and do this negative 1/10. So I'm headed to my check. Let me switch back to blue. So everything in blue stayed the same. Oops, I want a 7. Equals, and then minus 3/5. And for some reason, I've got this one a little lower than everything else, so I'm going to move it up a little bit just because I can. All right, so actually, I would have went ahead and maybe readjusted this fraction and made this over 10 while I was doing it. So let me back up and do that. I could easily use a third step to do that, but I don't want to run out of space. And so this would be 5 times what is 10, so that'd be 2. So 3 times 2 is 6. And so negative 7/10 stays the same on this side. And I would have negative 1 minus 6, which is negative 7 over 10. And this is a valid check, so a high probability of getting this answer over here correct. Okay? All right, so that's going to bring us to the end of this video. Hope that helped you out. If you have not subscribed, I would appreciate that. As always, you can like, share, or comment down below. And this is Mr. AlgeBraun signing off. See you later.